Last class we saw about the design rule checking and based on what are the parameters those design rules are checked and how it is carried out in PCB designing software tools. And then we saw about rack lines. Okay. Today you will see PCB fabrication process. That is the PCB fabrication process and the methodologies carried out in PCB fabrication houses. That is how PCB is fabricated nowadays in PCB designing companies. We are going to see it in a step-by-step process. Okay. Everyone go to slide number 2. Okay, the first step done by any PCB fabrication houses, PCB design and layout. Okay, that is for your PCB, you have to do the design and you have to layout it. Okay, it is done by means of some PCB designing software tools. See in the slide number 2, we are having example software tools, that is Altium Designer, KiCad, Cadence, Menta Graphics, ECEDA. We have worked on online ECEDA tool and then Eagle, Proteus. These are the PCB designing online tools. Using any of these tools, first of all, the company or the designer, if a person designs the PCB, he will be doing it in any of these software tool. First of all, that is first he will draw the schematic diagram, then he will convert it into netlist, then the netlist will be converted into layout diagram, that is PCB layout. From that routing and placement, everything will be done. All these things we have seen. These are the steps done in softwares. After doing this, either all these software designing will be done by the designer personnel or it will be done by the PCB fabrication house itself. Okay. If the designer does all these PCB design and layout, means all this information will be given to the PCB fabrication house, so that the PCB fabrication company can utilize the design from the designer. That will be transferred in form of Gerber file. I hope you all remember Gerber file. It is a design file. It has all the information, design information about the PCB design. Okay. So that Gerber file and all the associated documents will send to the PCB fabrication house. Why it is important means it only has the PCB width of the roots, then how different elements are connected, then how vias are placed, that is the holes are placed in the PCB board, and what are the specific size of the holes in the PCB board. All those information will be available in the Gerber file. So this Gerber file is used by the PCB fabrication house for manufacturing the PCB board in real environment. Okay. So this is the first step in PCB fabrication process, that is creating the PCB design and layout. So go to slide number 3. So after obtaining the Gerber file and the associated design document from the designer, the PCB fabrication house will run the design for manufacture check. Okay, that is they will be checking all the designs given by the designer, whether it is as per the design guidelines or not. We have already seen some design guidelines. It is a preferred size, preferred spacing, all those we have already seen. So based on that, they will run the design for manufacture check before fabricating the PCB board. Okay, these things will be done in the PCB fabrication house. Okay, next pre-production will be done. This will be done by pre-production engineers. That is the customer will send the associated documents. The engineers will review those documents and generate accurate quotation for those documents, and then they will be checking whether the product documents are correct or not, whether in that document some data are missing or not. If it is missing means if some document or if some data for a PCB fabrication is missing means it will be asked from the PCB designer. Okay, so all this checking will be done in the pre-production stage. Okay, so they will determine the process step and associated checks with that PCB designing. So this is pre-production stage. And next, go to slide number 5. The next second stage is production prepare. So next we are going to prepare for the production of PCB board. So at this stage initially we'll be having cut lamination. So cut lamination means first of all you have to know what is laminate. The laminate of a PCB is what the layers hold together. Okay, all the layers holding together is the laminate. Okay, all the layers in the PCB hold together is laminate. We have to cut that laminate sheet. See in the image provided in slide number 5, there is a left side image. The image provided in the left side, this is an machine which shows how this laminate is cut as per the finished board size or size of the panel. Okay, as per the customer requirement, there is a finished board size or size of the panel. The laminate is cut first of all. First will be cutting the laminate. Then this laminate will be subjected to drying. See, the drying is done by the personnel shown in the right hand side image in the slide number 5. See, this drying will be done to remove the moisture in the board. If there is any moisture in the board means it will be removed. So this drying is done at a temperature of 150 degrees Celsius. It is done for at least 3 to 4 hours. There is a drying process is carried out 150 degrees Celsius for 3 to 4 hours. This drying will prevent warping of the board during some processing. Warping means due to some heating process, the board may get a breakdown. So to prevent that, first of all, we will dry the PCB board. Okay. And next, go to slide number 6. And next, the third stage in a fabrication process is inner layer imaging. That is, in a multi-layer PCB, we'll be having so many layers. First, we'll be performing imaging. That is, we will be transferring the image in the inner layer. Okay. Then go to slide number 7. This inner layer imaging is done in 2 steps. That is the first one. Inner film is applied on the board. That is, the dry film is applied to the bare copper board and all the photo image reactions will be performed on the dry film. Okay. So in inner layer imaging on the bare copper board, the dry film is applied and some photo image reaction will be performed on the dry film. See, the image in the left hand side in slide number 7. In that image, you can see on the copper Okay. So in inner layer imaging, the inner film is applied. After that, the inner exposure is done. This inner exposure is done by the machine provided in the right hand side, slide number 7. See, in the inner layer development, the exposed copper is developed. See, in the bare copper, we are placing the dry film. Okay, so the dry film is photo imaged also. The surface not covered by the dry film, that is exposed copper surface will be developed, and the dry film will be remaining as it is. Okay, so in the bare copper board, the dry film is applied and then it is subjected to photo imaging. All those photo imaging is carried out on the exposed copper surface, not on the dry film. Okay, and next go to slide number 8. So these imaging process is done by photo imaging technique, that is by means of photo plotters. We have already seen two types of photo plotters. One is vector photo plotter. So normally we'll be using raster photo plotter in PCB fabrication houses and all. Okay. So this photo imaging is a main process for open and short circuit identifying. Okay. So in the boards, we'll be having some open circuit, some short circuit. For that, we'll be performing this photo imaging process. See, during this fabrication process, the personnel, as the operator of the machine, will be wearing some special dress. See, as shown in the figure in slide number 8. So go to slide number 8. So these cloths are anti-static cloths. So these cloths will be worn by the person performing all these operation in the PCB fabrication houses. This is because to prevent the electronic components from damaging by human. These personnel who are performing these operation in PCB fabrication house will be subjected to some air shower also. There will be a air shower door before the PCB fabrication house. After that air showering only, that person will enter into the PCB fabrication house wearing this type of anti-static clothing. Okay. This clothing is used by the personnel to prevent those components from damaging. Okay. Next, go to slide number 9. So next step is inner layer etching. See, we have applied the photo film in the inner layer and that photo film is developed also. Then the inner layer etching is performed. Inner layer etching means here the copper skin, the copper surface covered by the dry film is protected. Okay, we are having a dry film. The dry film is subjected to some photo image. Okay, the copper layer which is covered by the dry film will be protected, and the other layers which is not protected by the dry film will be etched away. Okay. After that, the film will be unloaded. That is, the dry film will be removed. Okay. This is done by the equipment shown in slide number 9. You can see the right hand side equipment. Okay. This equipment only will perform the inner layer etching. Okay. It is etching the copper surface. This is exposed. Okay. After that, the film will be removed. You can see the PCB board available on the right side of the slide number 9. That PCB board shows the board after inner layer etching. Okay, this is how the board will be After inner layer etching, next go to slide number 10. After inner layer etching, inner layer AOI is done. AOI means automatic optical inspection. Okay. Next, it is inspected. There is a board is inspected to check whether the copper plate after etching has some short circuit or open circuit. Whether there is any short circuit or open circuit is checked by means of optical inspection. Is done by some machinery equipment, and it also checks after etching. Etching means you are removing the copper. After that, whether the copper plate is clean or not, whether there is some leftover or not. Okay, whether the copper is not properly etched. All those will be checked in this stage, that is automatic optical inspection. It is done by the machine in PCB fabrication house. Next, go to slide number 11. The next step is lamination. There is a copper foil. See, in the lamination is done by the machine available in the left hand side of the slide number 11. This lamination, there will be several copper laminate. In between the copper laminate, will be having pre-plug. I hope you all remember pre-plug. This pre-plug is inserted between different layers in multi-layer PCB board. This is a insulation material. Okay. So adding all these layers, these set of layers will be pressed onto the board through the pre-plug layers. That is lamination. Lamination means we are arranging all these layers of laminate together with the pre-plug layer, and it is pressed under high pressure, so that will be obtaining a single board. Okay, that process is known as lamination. Next, go to slide number 12. So in slide number 12, you can see the next step, that is drilling. Drilling means you are going to create a hole on the board. Okay, that is you are going to drill the hole on the board. See the equipment shown in slide number 12. There is a drilling equipment. See in that tip of the equipment, it has some needle-like structure. That is nothing but your drills. This drill may be a tungsten carbide drill or diamond drill. Okay, that tip will be triple tip layer. Okay, so that you can drill the board to a particular depth. Okay, likewise drilling, that is creating hole in the board, will be done in PCB fabrication house. Then the next step, go to number 13. Next, electrolysis copper deposition is done. That is, after drilling, the hole is coated with copper. There is a thin layer of copper is coated along the hole. The thin layer of copper deposited by this electrolysis copper deposition will have a thickness of 2 to 3 micrometer. Okay, that layer will be a thin layer. This of 2 to 3 micrometer. See in the figure shown in the slide number 13, the detailed step in copper deposition is shown. First, the board is submerged in a sweller, and then will be etching by means of some chemical solution, then neutralized, then some conditioned will be done, then pre-dipped in hydrochloric acid, then we'll be using palladium catalyst, that is for speeding up the process, then thin stripping will be done, then finally copper is deposited on the board surface, that is on the whole surface. Through this electrolysis copper deposition, the hole will be coated with a copper of about 2 to 3 micrometer thickness. Okay, and next, the next ninth step is horizontal electrolytic plating. Here, in this electrolytic plating, the copper will be covered on the whole bare board, okay? The whole bare board, and also in the hole, this copper will be coated. Here, the thickness will be 5 to 8 micrometer, and this process is done by means of electron transfer reaction. In previous stage, we saw the process by means of electroless copper deposition. Here, this horizontal electrolytic plating is done by electron transfer reaction. Next, we'll go to next step. So, till now we have created the inner layer, and the inner layer is photo imaged, and the film is removed, and it is ready. Next, we have to create the outer layer. Okay, the step 10 is outer layer imaging. So, go to slide number 15. In slide number 15, you can see a small slab of outer layer imaging. That is, we have already drilled the hole. So, in outer layer imaging, the dry film is applied to the copper board, okay? Similar to the inner layer imaging and the outer layer imaging also, the dry film is applied to the copper board and it is photo imaged on the dry film. Here, the dry film is attached to the plate to protect the hole, okay? Here, already the board is holed by means of drilling operation in the previous stages. After drilling only, applying this photo film in the outer layer and it is imaged. So this dry film will be applied to the hole also, okay? And next, go to slide number 16. In slide number 16, left hand side you can see the photo outer layer coated with photoresist. See, this is how the dry film will be covered over the outer layer. And next, after the exposure, we'll be having the image as shown in the right side. That is, the outer layer will be exposed. Some portion will be exposed and it will be removed away. That is, in outer layer exposure, after the outer layer is developed, the copper film, the copper in the dry film is the last copper to be etched. So the copper needs to be preserved, is exposed at this time. Okay. Here, the copper which needs to be preserved will be exposed. Okay. This is in case of outer layer imaging. And then go to slide number 17. The next step is graphic plating. So in graphic plating, we are having thick copper plating. Till now we had thin copper plating. After outer layer imaging and exposure, that is a development of outer layer, we will be having graphic plating. That is for applying thick copper plating. Here the finished, that is a final copper plating, will have thickness of about 18 to 25 micrometer. Okay. This thick copper plating will be of 18 to 25 micrometer thickness, and then we'll be having tin plating. This tin is applied to the copper surface to protect that copper from corrosion and all. Okay. Then the next stage in graphic plating is removing the film. That is getting rid of the film. After the thick copper is plated and a thin tin is plated, the copper surface will be left exposed. That is, the outer layer film will be removed completely. Okay. So the dry film attached to the board is now removed, and then the copper under the dry film is now exposed. The remaining areas will be covered by tin. Okay. Here, the copper surface under the dry film is exposed because we have now removed the dry film. But there is a tin coating. Okay. For some portion of the copper. Let's go to slide number 18. So in slide number 18, we can see outer layer etching process. So here the outer layer is developed and then it is subjected to etching. Here in this etching process, the exposed copper only is etched away. The copper protected by the tin will remain. After etching, the tin surface will also be removed. Okay. This is outer layer etching. And then the next step is solder mask. So in this solder mask coating, the entire panel is coated with the liquid solder mask. Okay, we'll be having a liquid solder mask coating, and then here the board is exposed to high intensity ultraviolet radiation. This solder mask is coated to protect the copper surface from oxidation or some damaging or some corrosion. To prevent that, solder mask is coated over the board. Then the next step is seal screen. So go to slide number 20. So I hope you all will be aware of seal screen. Seal screen provides the information on the board. That is some print information will be provided on the board by means of seal screen. Okay. See in the figure in slide number 20, you can see the seal screen. It is given in that yellow color line and all. Okay. Likewise, we'll be having the seal screen. And the next process, go to slide number 21. And the next process after printing the seal screen is surface finish. Okay. The surface finish is used for protecting the copper surface only. Okay, go to slide number 22. The surface finish is used for protecting the board as well as for providing good solderability. And we have already seen some surface finish process, that is electroless nickel immersion gold or hot air solder leveling, lead free hot air solder leveling, immersion silver, anti-oxidation. So all these processes have already dealt in manufacturing stages itself. Okay. So these processes are used for coating the board with surface finish. We are coating the board with surface finish to provide good solderability as well as to protect the board from oxidation or corrosion. Okay. Next, go to slide number 3. And the 16th stage is profile. Profile means here we'll be creating a shape program on the border. Okay. The shape program will be given by the customer, that is by the designer. So based on that, milling will be performed. Milling means it is a process. This milling is a process of removing the copper areas from the PCB board to create pads, signal traces and some patterns. Okay. For this, a shape program is generated based on the border. Okay. This will be done in profile stage. And next, go to slide number 23. Sorry, go to slide number 24. Okay, next, the other surface finish process will be done. That is, I hope we have already seen V-cut groove. Okay. Here, what is this V-cut groove means? You can see in the image provided in slide number 24. The below there are two images. You can refer any one image. See that image, we are having some V shape cut on the board on the top layer as well as on the bottom layer. Okay. These B-cut will be provided on some necessary portions on the board based on the Gerber data file. Okay. Based on the Gerber data file, this B-cut will be provided on the board with a specified dimension from the Gerber data file. And next, go to slide number 25. Then gold finger will also be applied. What do you mean by gold finger means, and why you need gold finger? This normally will be having some connecting points on the PCB. So all these connecting points will be subjected to some constant plugging and unplugging. So if you're having some connector in the PCB board means will be plug something and will be unplug something. So this plugging and unplugging will create some wear and tear. To avoid that, we'll be having some strong contact edges. Particularly on the edges, we'll be having some strong contact that will be prone to wear and tear and cause the device malfunctioning. To prevent that, we'll be having a plating of some metals like gold. Okay, we'll be having a gold plating. See in the figure shown in slide number 25. See in the figure that in the PCB board at the edges there's some yellow color finger like structure. That is the gold fingers. So these gold fingers are provided to enhance the durability of edge connectors. So here if we have some edge connectors, that is we have some slot for inserting some cards. In your mobile phone itself you might have seen some gold plating and all. Okay, that is inside it. But in some devices like in your motherboard, in your PCB, you might have seen this edge gold fingers. It is for inserting card slot. Okay, to prevent wear and tear of the edge surface, we are going for gold fingers. Okay, this will also be done at this stage. And next, now the board is created. The next step is electrical testing. So electrical testing means we'll be checking the board whether the functionality is proper or not. Board functionality is proper or not. Here we'll be doing circuit continuity and isolation test. Whether the circuit continuity is good or not. Likewise, the testing will be going on. The basic electrical reliability testing used for checking is integration of tracks. We'll be having track. These tracks will only provide connection on the PCB board. Whether these tracks are properly integrated or the through-hole connections. We'll be having some through-hole connections. That is for providing connections from top layer to the bottom layer. So all these will be checked to ensure that the board is free from open circuit or short circuit connections. So this is done in electrical testing. So once the board is manufactured, electrical testing will be performed, and then we'll be performing visual inspection. Go to slide number 27. The next step is visual inspection. That is after creating the board and after subjecting the board to electrical testing, we'll be inspecting the board by means of our naked eye itself. That is this is normally done by the expert quality control team. They will be checked for finished product size. The product size will be inspected and the aperture hole number measurements will be checked and the warpage measurement will be checked. Warpage means this is a term is to refer the modified shape of the PCB. So all these measurement will be checked in visual inspection process This is a final inspection. So after checking and after the board is qualified, a test report will be generated, and this test report will be given to the customer for their reference. Okay, this is the final inspection. So after this, the last step is package and delivery. So after manufacturing the PCB board and after performing series of electrical testing and inspection and all, the board is ready for packaging. So normally this PCB is packaged in a vacuum sealed package. That is to prevent some dirt and moisture. We'll be packaging it in uh, vacuum sealed package. Okay. So these are the steps done in PCB fabrication house. So today we will see the quick recap of all the steps. So first step carried out in PCB fabrication houses, PCB design and layout. It is done by means of the PCB designing software tool. And then pre-production will be done. Pre-production means we'll be checking all the documents along with the Gerber files, whether all those documents are as per the design guidelines or not. After checking it, we'll be going for production. In the production, we'll be cutting the laminate for the preferred size, and then drying will be done. In drying, the board is dried at a high temperature to make it free from moisture and dirt. And then the next step is inner layer imaging. In inner layer imaging, the inner layer is subjected to applying photofilm, and then it is exposed, and then it is photo imaged. Then the inner layer etching is done. That is the layer which is not covered by the photofilm will be etched away. And the next step is automatic optical inspection. It is done by some equipment. The machine will check whether there is any open or short circuit or not. Then lamination process is done. Lamination means we'll be pressing all those sheets, laminated sheets, along with the pre-peg layer to form a multi-layer PCB board. Then the board will be drilled to create bias, that is holes. Then we'll be having electroless copper deposition along the holes created. Next, it will be subjected to horizontal electrolytic plating. That is, the whole board will be plated with electrolytic copper plating. Then outer layer imaging is done. That is, outer layer photofilm is applied and it is subjected to exposure. Thus, outer layer photo image is done. Then graphic photo plating. Here, the thick copper is covered on the surface. Then we'll be having tin plating to prevent the copper from damage. Then the photofilm will be removed off. Next, we'll be etching the outer layer, which is exposed. Then finally, the tin layer also will be removed and the desired circuit pattern will be formed. Then the solder mask layer will be applied. Next, silk screen will be printed on the board. Then the board is coated with surface finish to protect it from oxidation as well as for providing good solderability. For that, some process are involved in PCB fabrication houses. Then profiling is done. That is, a shape program will be created based on the border. Then other surface finishing process like V-cut on the bottom and the top layer will be done as per the given dimension. Then gold finger will be placed on the PCB board to prevent it from wear and tear, particularly to prevent the edge of the PCB from wear and tear. Then electrical testing is done to ensure the functionality for circuit continuity and to check whether there is any open or short circuit connection. And then final visual inspection will be done. That is, the board will be inspected whether there is a uh, whether the product size is correct or not, the hole measurement and the warpage measurements all are correct or not. Then finally, the PCB board after fabrication is packaged and it is delivered. Normally, this PCB board is packaged in a back and sealed package to prevent it from dirt and moisture. Okay. So now we will see this in a how this is done in a PCB fabrication house. Okay. For that, I'm sharing my screen. Everyone see, I'm using it in a mobile phone. So those who are using mobile phone can see the video in a full image. Those who are using laptop will see a small size video only. Sorry for that. After this session also, you can see that video. The link is posted in the WhatsApp group. I hope you all can see this screen. So here we are going to see the PCB designing carried out in PCB fabric house. Here we are going to see it in Saturn Electronics company. So first of all, we'll be going for CAD design. That is, the PCB software will be designed. See in the video, the operator will check whether the width and spacing are correct as per the design guidelines using the PCB design software. With the provided Gerber file, they will be checking whether it is as per the design guidelines or not. See, they will be checking the board whether it is as per the design guidelines, and then they'll be performing photo plotting. I hope now you can see the video. So here, using the photo plotters, the photo image is done on the photo film. So this is the photo film obtained after the photo imaging done in the software. And then we'll be going for inner layer lamination. See, first of all, the board is subjected to cleaning process. The copper board will be cleaned. After that, it will be coated with photo film. See, this ash color surface is photoresist. Then we'll be going for inner layer imaging. For that, we'll be placing the obtained photo film and the image which is obtained. Now it is pressed by means of machine. See, the holes are pressed. So these layers are pressed accurately by means of machines, and then we have obtained the inner layer lamination. Then we have to etch. So here the layer which is exposed will be etched. See, that blue color layer is the copper layer which is not etched because it is covered by the photofilm. Okay, the blue color layer is the copper layer which is not etched because it is covered by the photofilm. Likewise, these will be done in an automatic way, and then the operator will examine whether the photo image is done in a proper way or not. Then punching will be done. Punching means here it is done for aligning all the sheets. There is a small hole. It is not via. Small hole will be created by means of punching the sheet. Okay. The next automatic optical inspection is done. Okay, this inspection is done by the machine. So here the software generated image will be compared with the board. See, there is a small window opening, that is a software generated image will be checked against the real PCB board. The next step is oxide treatment. That is, we are protecting the PCB board, it is a copper surface, from oxidization. For that, we will be performing some oxide treatment process. That is, some surface finish will be applied here to prevent the board from oxidation or corrosion. And then
கால் பேக்க கொடுத்த வேண்டாம் கட் பண்ணு